Greetings and welcome. My name is Austin Walker, and I'm the Assistant Director of the Lumen Christi Institute. Lumen Christi was founded in 1997 by Catholic scholars at the University of Chicago, and our mission is to make the Church's intellectual tradition a living dialogue partner at the university and in broader society through courses, lectures, summer seminars, and virtual events like tonight. Tonight's lecture is a product of LCI's Newman Forum for high school students. The Newman Forum held its first event in 2019, and every year since it's held two major one-day conferences at the University of Chicago, a similar conference at the University of St. Mary of the Lake, a 4 or 5 day overnight summer institute, and a variety of smaller Socratic seminars and other events. The Newman Forum brings together high school students from Chicagoland, the wider region, and all over the nation in order to introduce them to the Catholic vision of intellectual life and culture, to prepare them to seek a robust liberal education wherever it is they attend college, and to offer an alternative to a narrow and secular account of life that sees science and religion or reason and the existence of God as at odds. I would like to thank the University of St. Mary of the Lake, the Archdiocese of Chicago, the Society of Catholic Scientists for their assistance in co-sponsoring this event tonight. I'd like to bring your attention to some great upcoming events we have, and I'll share them with you now. From July 8th to the 11th, the Newman Forum will hold its annual Summer Institute at the University of St. Mary of the Lake, July 8th through the 11th. They are guided by Notre Dame philosophy and theology professors Ginny and Jay Martin, who are also married. Students will study the three transcendentals: truth, goodness, and beauty. There will also be a trip to Six Flags. If you or a high school student you know would benefit from this Summer Institute, please encourage him or her or yourself to apply. We even have an early bird special for everyone who applies before May the 1st. We have a couple of events that are upcoming further on in the future, but I'll mention them to you now just to pique your interest. In November of 2021, we'll have a conference, Are You Friends Online? The Science and Theology of Friendship. And then in February of 2022, we're going to have a Faith and Science Fair in partnership with the Society of Catholic Scientists at the University of St. Mary of the Lake, where in addition to lectures and small group discussions, we'll have an inverted science fair where Catholic scientists will be standing in a room with their poster boards explaining their field of interest. And you as the students will get to go around and ask them questions either about their field of science or what it's like to be a Catholic and a scientist. Smaller events can be held for your parish or school with some flexibility, whether in person or online. Both my and my program coordinator's email will appear at the end of this lecture tonight. Please don't hesitate to reach out to us for more information. Now, you can financially support the Lumen Christi Institute today at the website www.lumenchristi.org/donate. Now, let's get to the main event. Tonight's event will be a fascinating look at an intersection of science and religion from the perspective of complexity studies. And I can think of no better guide through the field than the very Reverend John Carci. Very Reverend John Carci is rector, president, and assistant professor in the Department of Biblical Studies and Homiletics at Mundelein Seminary and University of St. Mary of the Lake. He holds a PhD in astrophysics from the University of Chicago, as well as numerous degrees from USML and the Catholic University of America. Ordained as a priest in the Archdiocese of Chicago in 2002, Father Carci previously served as the director of the Shield Catholic Center at Northwestern University and is the author of Wisdom, Epistemology, and the Psalter, a study of Psalms 1, 73, 90, and 107. Father Carci, I invite you to unmute yourself and to turn on your screen.
Great. Thanks so much, Austin.
Excellent. Thank you.
All right. And great to be with everyone here. Just going to get my screen share going. So, as Austin said, what I'd like to do tonight is introduce us, or if you're already familiar with it, get a little bit more deep into a fascinating area in contemporary science known as complexity theory. And I find it so interesting because it's so broadly applicable. It isn't necessarily biology or physics specifically, but it's the study of systems themselves. And anything you might be interested in science, if it's biology, physics, whatever, involves systems of atoms or molecules or agents. And so complexity theory is simply the recognition over recent decades that it's the relationship between agents and systems that in some ways is the most important thing to try and understand. Now, it should come as no surprise that that's also of great interest to any theologian, because think about how we talk about Christianity. We are the body of Christ, the different members of Christ's body in the world, the three persons of the Trinity, Father, Son, and Spirit. God is inherently relational, and we, in the image and likeness of God, are inherently relational. So I find complexity theory particularly fascinating as a doorway into the faith-science dialogue. And pretty much it hasn't been looked at, in this perspective. So if it piques your interest, there's a lot of new ground to explore. So as a way into this, what I want to have us do is look at a fascinating little film clip. And maybe some of you have seen this in real life, but a lot of times you'll find with certain species of birds, these extraordinary flocking behaviors. So I'm going to show you a little clip of some starlings. And if you're like me and you grew up around Chicago, you may not have seen this in the sky, but if you're in a more rural area, if you've ever traveled out into agricultural areas, you certainly might have seen this. So thousands and thousands of starlings moving together as a flock in the sky. And I promise you what you're about to see is not Pixar, it's not photoshopped. These are real birds, but just pay attention to their movement. You can pick up the sound, those aren't waves. Notice the extraordinary, almost choreographed movement. How they're turning, how they're dividing. This is spread out over more than a city block. We don't want to be standing under that, but it's amazing. Okay, well, you get the idea. I don't know about you, but I could watch that for a long time. So the big question is, how do they do it? How in the world do these birds manage these extraordinary, complicated movements? That one bird, can follow an amazing path in the sky, okay, maybe two or three, but how in the world do you get thousands of birds behaving in this incredibly synchronized way? How do they communicate? Who teaches them? Who trained these birds to do it? They're birds out in the wild. And it's that type of behavior that really got people thinking along the lines of asking these sorts of questions. And they're hardly new questions, but it's only relatively recently that people have had the ability and the interest to try and really dive in and say, how can we break this apart? How can we try to figure out what's going on, which is, of course, what scientists do. And I would argue is what good theologians do, right? Theologians and scientists are both fascinated by the world that is. Okay, well, let's take a simpler question. The starlings, they're moving through the sky. How do you make a swirl, right? A swirl pattern. Imagine you took a mop and you started twisting the handle. Well, we can imagine, the little strings of the mop would wind up. So you make a swirl seemingly by turning or twisting. Okay, makes sense. Here's an image of a hurricane. And largely, it's a giant mop, if you like. If you were down there at sea level, a dangerous place to be, but you would notice rotation, just like with the mop. Now, in this case, they're not swirling around because somebody's turning a handle, but because of the air currents on the surface of the earth, over the ocean, and so forth. But the point is, there's turning and there's forces that are circulating, not all that different from the mop. So again, thinking like a scientist, you're taking something that you know you can get your hands on and experiment with, spinning the mop. Now you see a similar type of behavior, and you can extrapolate, right? You can imagine, all right, well, maybe I don't exactly know what's driving these wind forces, but it's really very similar. I just got this whole thing rotating. Okay, so thinking like a scientist. Well, eventually telescopes are invented, and strong enough telescopes are invented that they start looking out into the heavens. And here's a beautiful example of a spiral galaxy. Obvious why they're called spiral galaxies. And so you see that kind of characteristic behavior, that winding, swirling behavior. And you would naturally come to the conclusion that, well, somehow this thing is being wound up, it's being spun around, and these arms of the galaxy are like the strings in the mop, or they're like the winds in the hurricane. But in point of fact, what we know today is that that's not what's happening. The galaxy is spinning, to be sure, but it's not spinning nearly fast enough to explain that sort of twirling pattern that you see. And we don't have time to go into it, but what you're really seeing in that spiral galaxy is the propagation of something called a density wave. And it just produces that type of pattern when you look at it from a distance. But locally, right, not unlike the birds in their flock, locally you just have gas and dust that's interacting with the gas and dust around it. There's no giant external force that is spinning the whole thing around. So already beginning to ask the question, if I get behavior that seems to be similar, I can't always draw the conclusion that I know what's causing it. In the case of the mop or the hurricane, I do have a sort of central force which is responsible for everything. But all of a sudden now I have what looks to be caused by the same sort of phenomenon, but I know, again, you're just gonna take my word for it, but astronomers can determine this pretty accurately, that this is not being spun around by some giant force per se. Well, how about this? You know, a conch shell. Maybe you've seen one of these, sometimes it's known as a chambered nautilus, very beautiful shell. In this case, it's been sliced, obviously, in half, to the great duress of the animal inside of it, I'm sure. But what you see again is that characteristic swirl pattern. And once again, you might think, well, okay, what's turning here? What's the equivalent of the mop handle, if you like? Well, not unlike the fact that in the galaxy, you don't have some giant swirling force. Similarly, in the seashell, you don't have something like that. This pattern that you see is really due to the crystalline structure of the calcium and so forth, the molecules that make up the shell. And it just so happens that the crystal shape, as you're growing from, as the shell grows from year to year, the way those nearest neighbor molecules interact with each other is such that you get this sort of a pattern. Very beautiful pattern, and you can see why someone might imagine there's a swirling force, like what makes a mop swirl or a pinwheel. That would be a logical conclusion, but in fact, it's not accurate. And so the question is, well, how is it the case that you've got these little, molecules and then crystals of carbon and calcium, whatever that goes into a seashell? How is it choreographed? How is it put together such that you get this beautiful pattern? And how can I get such similar patterns in the spinning mop or the hurricane or the galaxy or this seashell? There's got to be a similar sort of phenomenon that's driving it all. And again, this is where common sense wants to insert an answer, but that's why we have science. And you don't have to think of science as something special. It's why we have brains, right? You're just applying curiosity. And theologians do the same thing. Common sense says God is God and human beings are human beings. Don't try to tell me that God becomes a human being. That just doesn't make sense. That's not common sense, right? Well, welcome to Christianity. And all of a sudden our minds are blown. But scientists, good scientists, are familiar with that kind of experience. Oh, I thought I understood the way things were, and lo and behold, the world surprises me. All right, so let's look at one final example of a swirl. Little Scottish Terrier puppies. Dinner time.
Meow, 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 meow. Meow. It's a Scotty Pinwheel. Scotty Pinwheel.
Look at that. Now, is there any mop handles spinning them around? Are there any high winds that are causing them to do that?
I mean, faster you'll be airborne.
Not. Have they been trained to do that? Presumably not. They're just puppies trying to get their dinner, their lunch.
Good puppies.
Eventually the food runs out, and that's the
Matthew,
end of it.
Mark, Luke, John, Nigel, Annalise. Good, nice, healthy puppies. Get your goat's milk.
Okay, but think about what was going on there for a minute. What was happening is that each puppy, trying to get some food, is interacting with the puppy on its left and its right. That's all that's going on. You know, they're not talking to the puppy across the other side of the dish saying, hey, it's your turn, let's start moving. Each puppy is taking care of itself, but he or she is also aware of what's going on to the guy next to him or the girl next to him on the other side, right? And that's all that it takes. Once you combine that with the constraint in this case of, well, the milk isn't just all over the floor, it's contained in a central area. So what I'm getting at here is those puppies are a lot closer to the seashell than they are to the mop or the hurricane. You're getting this really beautiful and frankly very cute spiral pattern because what's happening is each agent in that system is simply cognizant, simply aware of what's going on with its nearest neighbor. Okay, so let's go back to the birds. How do they do that? Well, it turns out ornithologists, people who study birds, you know, they have some pretty good insights into how birds behave when they're flocking. And it turns out there are two main characteristics that the birds have which can lead to this flocking behavior. So the first rule is more or less keep an equal distance from your neighbors, right? So if you're flying too fast, you're going to bump into the guy in front of you. If you're flying too slow, you're going to get bumped into by the guy behind you. If you fly too close to the bird on your left or your right, you know, you're probably wings are going to clash and bad things are going to happen. So basically, if you're a bird in that giant flock, what you're paying attention to is, I want to make sure I'm more or less equidistant from the guys around me. And you can throw in above and below as well. So that's one rule. And that's, you know, that kind of makes sense, right? If you're crashing into everyone around you, there's going to be problems. The second rule, though, is probably not so obvious, at least it wasn't to me. And it's that these birds tend to always turn toward the center of the group. Now, of course, if you think about the shape of those flocking birds that we saw, it's not obvious where the center is. So center is always going to be sort of a locally defined term. But if you imagine you're a bird in the flock and, you know, you look to your right and there's only a few layers of birds and then it's blue sky, you look to your left and there's, you know, a very much denser population, you're probably going to reason that center is somewhere to your left. So you start heading in that direction. What they've done is, you know, what scientists have done is they've modeled this flocking behavior. And I'm sure a lot of you guys have done coding. You know, you can imagine the algorithm for this is not terribly difficult. You know, stay equidistant from your nearest neighbor. You could put in a random velocity generator. So some go a little faster, slower. They have to adjust for that. You know, you can come up with a pretty simple algorithm for what is the local perception of center based on where you are in the cloud and just turn in that direction. And lo and behold, you can reproduce, not to the extraordinary beauty of what you see in nature, but you can produce pretty closely this kind of flocking behavior that does behave in a somewhat unpredictable way. You set it up in some initial configuration and then you let it go. What's also really cool is using drones. Now experiments are done in this way, where you program the drone so that it behaves according to these two rules. The problem is, of course, we're not good enough with our drone technology to be able to send up 10,000 drones. But in computer modeling, as you can imagine, it's not that difficult to do. So for you coders out there, maybe I've inspired you to go play with something this weekend. So this leads us then into complexity theory, right? So it's one thing to look at behaviors and to start doing a little bit of experimentation. But of course, as a good scientist, you want to ask yourself, is there a larger context in which this makes sense? Is there a systemic way of understanding it? And a good theologian does exactly the same thing. Okay, I got this guy, Jesus of Nazareth, pretty interesting. Wow, he rises from the dead. Okay, we've gone to a whole new level. Well, I knew about the God of my ancestors, right? The God of ancient Israel. Now I've got the Son of God. Wait, there's the Holy Spirit coming. Are these just random things, or is there an overarching systematic way to think about it? And welcome to the birth of Christian theology, right? But that's exactly the way scientists think. It drives me crazy when we separate these things off as if, well, there's science and there's faith. Again, you either have a brain or you don't have a brain. And if you do, you're curious. So complexity theory talks about what are known as complex systems. A complex system, as any system does, it just has many diverse parts or members or agents. So these can be inanimate things, they can be birds, they can be human beings. But somehow they're highly connected, right? When you see the flocking birds, however it is they are connected, clearly there's something that's joining them together. In the bird's case, it's not a physical rope or something, but in the puppy's case, right? There's no wire that's strung through them, at least I hope there isn't, that's leading them to spin, but they are connected. In the puppy's case, they're connected by their desire to get some food. And the system has to be capable of adaptation or evolution. Okay, that's a real key point. For a system to be a complex system. So somehow the birds are aware of their nearest neighbor, right? Well, that's a form of adaptation. If they get too close, they have to move to the other side. If they're flying too fast, they have to slow down. That's a very simple example. So an example of complex system, we looked at flocking birds. These are schooling fish. This is a GIF, it's not a movie, so obviously it's repeating. But fish are no less fascinating. If any of you are divers, and you go to a coral reef or something, you see this kind of behavior. Look how seemingly choreographed they are. When the shark or whatever that is coming in, they get out of the way. Well, there's no way in the world, they've been trained to do that. Somehow, out of these thousands of fish, they manage to have this incredibly systematic behavior. How about melting ice, right? There's a glacier that's falling apart. Again, a system, all the little frozen water molecules in a giant chunk of ice. They are in some ways connected, and their behavior, large scale, is in some ways related. But you can't tell me that one piece of ice is necessarily communicated with another ice molecule that might be, 100 yards away. This also goes for human beings, right? Complex system. This is a parish, right? Feast of Our Lady of Guadalupe. Well, who are the agents? The agents are the people, right? The people in the parish, the priests, the parishioners, the ministers, everybody. They're connected. Think of all the different ways that the members of a parish are connected, right? We need to think about this when we talk about evangelizing. So all of these examples of complex systems. Another quality that a complex system has, obviously you need agents, right? That's the lowest common denominator there. But then you need something what's known as non-linearity, okay? Again, some of you may be studying a little bit more advanced mathematics, linear versus non-linear. Linear interactions are kind of just what they sound like, A bumps into B, B bumps into C, C bumps into D, if you imagine a bunch of bowling balls running into each other. And it's a relatively, simple accumulation of forces or influences. In a nonlinear case, that's not what's going on. Effects are produced by multiple interacting causes. And there's a disproportionality between the amount of input and the amount of output. Okay, what do I mean by that? Well, just a little bit of effort can lead to sometimes a catastrophic result. Let's look at an example. An avalanche would be a great example of this. You can start an avalanche at the top of the mountain just by kicking a little bit of snow if the system is unstable enough. Okay, this is non-linear. In other words, one snowflake impacts 2, impacts 5, a million, and pretty soon the whole mountain is cascading down on top of you. It's sort of an exponential growth of influence. And a relatively small input, right? Somebody just kicks a little snow at the top of the mountain, leads to this extraordinary output. So this is a classic example of non-linear behavior. Some of you may be familiar with what's known as the butterfly effect, right? So talking about how air currents can grow and be amplified in the atmosphere. And so nobody's ever actually measured this, but it's an interesting hypothesis. So the way it goes is a butterfly in Africa flaps its wings and it sets off this very gentle little air current, right? And that affects some other air molecules, and that affects more, kind of like the avalanche. And eventually what happens is you get a wind stream now going above Africa. It crosses the planet, it grows, and it literally leads to a hurricane, somewhere in the Caribbean, whatever. Again, non-linearity. So it's not just the few air molecules that the butterfly can move that's affected, but they move others, and the whole thing begins to grow. Another quality of complex systems is that networks are key. And what do I mean by networks? Well, kind of just what we normally use that term for, that you have these nodes or these centers, if you like, throughout your system, and that they are connected, they communicate with each other. Notice how in all of this, we're not just talking about biology, or we're not just talking about chemistry, or we're not just talking about physics. This is very general language, and it's intentionally so, because it's describing fundamental behaviors about the natural world. So if those of you fly a lot, well, not a lot of us have been flying a lot over this past year, but think of how airlines are set up, the hub and spoke model. It's not the case that you can just get a flight from any town to any other town. If these are not highly populated towns, then, sometimes if you want to go from Minneapolis to Nashville, you might find yourself going to San Diego first and then Newark, because that's the way that particular airline is set up. There are certain hubs that they use. So interconnected nodes. The connections between these nodes can have a wide variety. They can be physical. They could literally be connected by wires, right? Think of the mop swirling. All those strings are connected to the wooden handle. They can be virtual, right? Cyberspace. Think of the networks that we have through the internet. The very name implies that, internetwork. They can be emotional, right? Human beings can be deeply connected in a network because they care about the same cause, because they're grieving the same loss. Traffic patterns. Every large city has traffic engineers. Some of you guys might be interested in city management. You can get a doctorate in traffic management. Really a way of studying how do traffic patterns evolve. And there are certain nodes or points of connectivity, right? Areas in a city, areas in a town, across a large geographical distance where people want to get to and travel. Gamers, right? Think about this. Think of how you are connected to hundreds or thousands or even more, through online gaming. Now think about all the ways you're connected. There's a virtual connection, but there's also a physical connection. You're literally using the device that you have. There's emotional connection, right? Sometimes people's emotions in gaming are stronger than the emotions they have in non-virtual life. And that's a little scary, right? Try not to be that person. But all these different ways that we can be connected. And for a complex system, networks are key. Another quality for a complex system, it has to have the ability to adapt and evolve, right? And that means you need some kind of feedback mechanism, so that as the system is moving, as the agents are moving along and something changes, they can react to it. If the bird gets too close to its neighbor and they start bumping wings, He can steer himself in the other direction. He can speed up, he can slow down. Think what this looks like with traffic, right? You get a traffic jam, everyone isn't doomed to just sit in the traffic jam. You can make adjustments, you can make changes. And so you get real-time adaptation where you're responding to what's going on around you, and that can lead to long-term evolution, right? So these changes can actually be integrated into the system. So don't just think of evolution the way we often talk about it with, evolution of species and so forth. Traffic patterns can evolve. The internet certainly evolves over time as it's grown. So complex systems can adapt by responding to changes in their environments, and they can evolve over time by responding to those changes. So here's an example of the evolution of structure in the universe. This is something I worked on when I was a graduate student. So what I'm just showing you is a model simulation of things that we actually see, though, of structure that you begin to notice as you go down to smaller and smaller scales. So the formation of structure or the organization of structure in the early universe is an example of adaptation and evolution. Climate change, what I'm showing you there is a color-coded animation, but representing real data of climate change on the Earth. Well, what you have is the Earth itself, the atmosphere, adapting and responding to changes being caused by everything from, solar sunspot phenomenons to obviously what we're doing on the Earth, burning of fossil fuels and so forth, ocean currents, all kinds of things coming into play there. And obviously a lot of concern these days over, are we as the human species disproportionately affecting, leading to serious climate change on a scale that's going to outrun our ability to deal with it. At least that's the fear. But the planet itself responding to that and evolving, right? We all know this. Areas that are traditionally colder are warming up, and that's just raw data, right? There's no conspiracy theory there. Finally, something that characterizes a complex system, and this in some ways is really the most significant, is what's called emergence or self-organization. So a lot of what we've looked at you might expect just to be random and chaotic. Throw 10,000 birds in the sky and I would just imagine, oh, they're going to fly all over the place. It's going to be a train wreck. Well, in fact, what you see is these beautiful patterns emerging, almost as if somehow they are organizing themselves, right? And yet we know all those birds can't possibly be communicating with each other. That's impossible. So it's this nearest neighbor communication, which is leading to a globally emerging pattern. And here's where we're still faced with a lot of mystery, right? Trying to understand, how do you go from this local level of communication to a global level of pattern? So global coordination arising from local interactions, because there's no centralized coordinator. There's no chief bird in that flock who's standing there pointing to everyone saying, hey, you go here, you go there. Traffic flow in a city, there's no centralized coordinator. Yeah, you've got stoplights and stop signs and things, and that helps locally, but globally, nobody is directing it. And yet on a global scale, there are recognizable flows and patterns and structure to the way traffic works, for example. These patterns seem to emerge spontaneously, and yet it isn't just randomly, right? The puppies, if I had asked you before the milk went in there, what's it going to look like? Well, you might have just thought they'd all stay in place and they'd get their milk, and maybe they'd nudge themselves. But unless you'd seen it before, you probably wouldn't have predicted that they'd go into this, rotating pattern that gives you this nice swirl structure. So these patterns seemingly emerge spontaneously, and yet at the local level, we know something about, what's the science or what's the degree of interaction that's happening there. So an example of this, these are ants. Okay, so you've got a pipe there, and the middle piece of the pipe is missing. And so the ants are coming out one tube, and they realize, hey, there's just air, empty space here. How are we going to reach the other side? Ants will self-organize. So those aren't ants that are crawling on a wire or something. There's no wire at all in between. The ants themselves form themselves into a bridge. How they do that is still unknown, how they communicate at that level. And this is spanning a relatively small area. I mean, they can literally do this to cross rivers. They form human bridges out of themselves. Yet individually, you put two ants together on a tabletop, they just sort of wander around aimlessly. Here's an example of that emergent pattern. When in their nearest neighbor interactions, they don't show this kind of behavior. They're just ants moving along. Put thousands of them together. This comes out of some research at my alma mater, the University of Chicago. And what you're actually seeing is the formation of protein structures. Okay, so I get it. You look at it now, it's just kind of a pretty GIF, but what they're beginning to see is the emergence of highly structured molecules, kinds of molecules of life, right? Because this is a question that people who are interested in the origin of life are very fascinated by. How do you take this sort of primordial soup of carbon and amino acids and so forth and get that into the structure that we know to be living? Now, if you're a person of faith, that shouldn't frighten us. That doesn't mean there's no role for God. What if what you have in the organization of the very first primordial life on the planet, what if that is the result of some of this complex system behavior? Who's to say God isn't responsible for that? But when we're getting into the question of, well, how is God acting, right? And so as science gives us more of a window into the behavior of the natural world, all that does is that enriches the way theologians can talk about that world and how God is present in that world. So all the greatest theologians, Augustine, Aquinas, John Henry Newman, right, the namesake of this amazing society forum, these guys and women, they loved the information, the knowledge of their day, and they would use that to help unpack how they thought and talked about God. So in our last minutes here, let's get very specific on what are some of the religious implications of complexity theory. Well, for one thing, I think it has a lot to add to the discussion about primary and secondary causation. Okay, so maybe you've talked about that in some of your classes. You haven't, don't worry. I mean, primary cause, if you like, you want to say God is responsible, we would say this is people of faith, for everything that is, right? The universe exists because God desires it to exist. It's a manifestation of God's love. That doesn't have to mean that God is going down, with his divine finger, pushing around every atom and molecule and, causing avalanches to happen and pushing cars here and there. That's secondary causation. And our Catholic theology and philosophy, no, that's not the way we understand God. God could act that way, but it's not a way, that we generally see or observe. Well, when you start talking about something like complexity theory or a complex system, what you begin to realize is that even what we, quote, normally mean by secondary causation isn't so clear. Right? So what I've shown you on the left is a model of the Big Bang, the early universe, where you have this incredibly high density, kind of random chaotic soup of photons and electrons and so forth. And relatively quickly, structure begins to form in the early universe. You start getting galaxies and stars pretty quickly on. On the right, what you have is a modeling of DNA replication. Okay, so it's a model, yes, but it's based on some highly exact science. And again, when biologists, molecular biologists, look at some of these processes, they're using things like complexity theory, where you simply have all these agents who can't possibly be communicating directly with millions or sometimes even billions of other agents in the system, and yet you get this highly structured behavior. So secondary causation, right? Really start scratching your head a little bit when you look at something like a complex system. Yes, nearest neighbor interactions, I'm bumping into you, my electric charge is interacting with your electric charge, and that's causing you to be pushed along the road. But what's causing this large scale behavior, right? And that doesn't necessarily mean that's a sign of God's primary causation, because God's primary causation is somehow underlying the existence of everything. So the causation that's happening within a complex system is kind of pushing to the limits how we think about secondary causation. So I haven't satisfied any of you by raising that question, and I hope I've frustrated you, right? This is a great question for philosophers to think about and to take on. All good science raises good philosophical and theological questions, and vice versa. And finally, and this is really for myself, I mean, I teach at the seminary when I work with seminarians, but I would say this to everybody on this Zoom webinar. Think about the implications of this for evangelization. I think in the Catholic Church, we do ourselves a disservice by having all these superstars, right? By superstars, I just mean, you know, somebody who's got 10 zillion likes or watches on their YouTube videos or the podcasts everybody listens to. I mean, that's fine, right? We should all listen to good guides, but at the end of the day, it's that nearest neighbor local interaction that is responsible for the growth of the faith. You know, you watch an amazing video, you hear a great, you know, podcast, then you turn it off and you go on with your life. The little scene there, I'd like to imagine, maybe it's a high school student holding on to the hand, you know, of an elderly grandparent. You know, maybe not in COVID, unfortunately, we can't do it that way, but there's still ways of interacting. But it's that nearest neighbor interaction. It's that sharing of the faith. It's asking, hey, how are you doing? Or did you hear that, you know, the gospel we read at Mass today? What did you think about it? Or, hey, I have this question, you know, I'm really wondering about what I should do with my life. You know, what do you think? How have you experienced God in your life? And it's those nearest neighbor interactions that I think transform the larger Christian populations. And so my final thing that I'll just say here is I've got a little bit of experience with, you know, parishes. And when you find a really dynamic parish, almost always it's not because they have Father Superstar, you know, or it's one guy who's, yes, I hope they have a great pastor or priest. But if that parish is alive and vibrant, it's because there's dozens and hundreds and thousands of nearest neighbor interactions. It's little groups and clusters who are communicating, and then that communication spreads out. And when that's going on in a parish, you have a well-evangelized community. So a lot more could be said there, but what I'm excited about at the blending of complexity theory and theology is precisely because I think it has huge implications for evangelization. And I guess we'll open it up now for questions or discussion.
All right. Thank you so much, Father Carchi, for this lecture. I know it's hard over Zoom, but I imagine everyone giving you a round of applause from their respective homes. So thank you again for this lecture. Yes, now is the time for Q&A. So for those who are listening, if you have any questions and haven't yet popped them in the Q&A box, which you can find at the bottom of your screen, now is the time. Let's see, got a lot of thank yous in the questions. Okay, let's.
Here you come to the summer seminar at Institute, Summer Institute.
Yes, I believe Father Karshi described it as his backyard. It's up at Mendel.
Right, that's right.
So if you come up to the Summer Institute, you'll be able to see him and learn more. All right, so one question I see is, someone is curious about the music heard during the clip of the birds. Was it in the clip? I think it was the sound of the birds, but was there music during the?
Yeah, no, thank you so much for asking that question. It wasn't music, it was the flapping of their wings. And what it sounds like to me is actually ocean waves, but it was not music. That was what you would hear.
Very cool.
On their wings.
Someone is asking for any book recommendations you have on this topic.
Yes, a great book, and I don't know if you're familiar with the Oxford series called A Very Short Introduction. They take all kinds of topics. So there's a very short introduction to complexity theory. That would be one I would recommend. The other thing I would say is that, you know, YouTube has some really great videos on it, and sometimes that's a good place to get your feet wet.
All right, we have a question that says, science is an experimental subject. Is there such a thing as experimental theology?
Yes, absolutely. All theology is experimental. Theology and science are both driven by data, and never let anyone tell you otherwise. Data doesn't mean test tubes and white lab coats necessarily. It just means what you observe, right? So all theology began with observation. Nobody reasoned to the fact that, well, God will become human and then he's going to rise from the dead. That came from encountering, the man Jesus of Nazareth and observing what he's doing. Now today, right, in our world, if you say, is there experimental, what I would say the laboratory for faith is prayer. If you don't pray, you don't have the right to make conclusions about the faith. And I mean that very strongly. If you're a scientist and you don't experiment, you don't have the right to make claims about science. Now, faith takes some work, right? It doesn't just come easily. So seek out a good mentor, your parish priest, your religion teacher. I'm right across the street from Carmel Catholic High School. They've got amazing chaplains and faculty members and whoever you are, seek out that person, or your parents or siblings. But prayer is where you say, Lord, I'm really struggling. I don't know why that bad thing happened to a good person. Why did my grandmother get COVID? Well, don't just sit there and stew over it. Tell God that you're angry. And if you're not quite sure how to do that, go to the book of Psalms, learn to pray as a young adult. That's for me, that was a huge transition point. I was taught how to pray, in second grade, but as a young adult, that just wasn't working for me. And I had to learn, but look how hard you guys are working. You take AP this, AP that, well, take AP prayer. It's well worth the effort, I promise you.
That's awesome. Okay, we have a couple of questions along the same line. How would you describe your own faith journey and education as a scientist? Generally, how did you get interested in these topics?
I was always fascinated by, sometimes I wonder if it's a gene that you just have or you don't have, but yeah, I just, I was that kid who would play around with bugs in the backyard, and but astronomy was always my passion. And even though I grew up in, the south side of Chicago, Northwest Indiana, where you rarely see things in the night sky, you could see the moon and you could see the sun. And, it was around the time the Hubble Space Telescope went up. And so it just fascinated me to know that that was out there, right? And I wanted to know about it. And then I was very blessed to have a liberal education. And that's why I'm such a huge fan of the Newman Forum. Because I would always say, if you're interested in science, don't just limit yourself to science books. Read deeply in the humanities. Science is metaphor, right? Almost all science is metaphor. You're looking at something that you can never completely understand, and so you're modeling it. You're trying to come up with language to describe it. That's what poets do, and I'm not joking when I say read good fiction, read good poetry. Because for me, as I was, I was very blessed and privileged to be able to do that at the University of Chicago. And that just, only increased my interest. So don't let someone tell you that, you can't do it, or you have to go to this school or that school. Especially in the era of today, so much stuff is accessible online. But it was just curiosity. And that's what drives me as a priest today. It's that encounter with mystery at the end of the day. That's what a scientist shares with a theologian. We both encounter mystery.
This question actually might be related to what you just said. Someone asks, we know what evidence-based means in science. What does it mean or look like in theology for something to be evidence-based?
And so it obviously doesn't mean exactly the same thing, because in the case of science, you want to reproduce a result that you see. If something only happens one time, and then other people try to reproduce the experiment and they don't get a similar result, that's going to be highly suspect. That being said, a lot of times people make the mistake, I think, of imagining that, well, faith is not evidence-based. That's not true. Otherwise, why bother to have faith? So, for example, when you baptize a baby, well, why do you baptize a baby? It doesn't, the grace of baptism, Doesn't prevent the child from getting, a cold. It doesn't weigh anymore. You can weigh a child before and after baptism. It doesn't weigh any differently. But I think the mistake we as people of faith sometimes make is, well, that's just abstract or that's spiritual. Baloney. I don't think that's what Paul meant when he talked about the gifts of the Spirit, right? Wisdom and patience, fortitude, and all these good things. Now, it's not voodoo, right? The grace does not force you to behave in a certain way. But why is that baby baptized? Is there evidence of the impact of baptism? Well, let's go to a little theology. For us as Catholics, grace is a fancy word for the love of God, if you like. That has to be received. It has to be cooperated with. So why is that baby there being baptized in the first place? Because it's a manifestation of the parents' love. It's a manifestation of the grandparents' love. They didn't just walk down the street and find a baptismal font. The fact that the font is there in a church, in a parish, that's a manifestation of the body of Christ. Now, if everybody is aware of that and they're trying to live it out and make it real, right? As that little kid grows up and somebody tells them about the fact that they were baptized as a manifestation of our love, and let's read scripture and I'll teach you about adoration. Then here's where the supernatural begins to come to the fore, because this isn't just human effort. The scientist is simply working with their human effort and their human reason. God is woven into that, sure. But in the case of prayer or the sacraments, but those sacraments manifest themselves in our lives. And I really believe this, guys. If you go to your studies as people of prayer, if you go to your studies, having experienced the freedom of the sacrament of reconciliation, if you go to your studies being somebody who, is a regular attendee at Mass, you are going to derive something more from the exercise of your intellect than if you didn't do those things. Now, an atheist can roll his eyes and say, oh, that's ridiculous. But have you actually talked to someone who's lived that way and approached the life of the mind in that way? I have, and I've been incredibly enriched by that experience. So it's not the same kind of evidence, but there are things you can point to. That's why the saints are attractive to us in some level. And not just the saints who, there are amazing stories, they levitated or something. Most saints don't do that. Most saints just, walk on the ground like the rest of us. But what is it that draws us to them? Well, it's something in addition to their humanity. It's the fruit of their prayer. But you got to roll up your sleeves and you got to be willing to explore that and learn about it. Good theology is work, just like good medicine or law or music is.
Absolutely. We have a question that asks, are there any accessible educational resources that helped you stem your knowledge before college or while in high school, or any resources that you know of for high school age students?
Yeah, well, in the sciences, and probably a lot of practicing scientists would say this, Richard Feynman's lectures on physics. Richard Feynman has kind of become a little bit more of a celebrity. I mean, he's gone now from the scene, but he has a series of lectures on physics that any high school student, could find accessible. That's if you're interested in physics. Again, these days with the internet, I wish I'd had that when I was in high school, because there just are some really great, the NASA website is amazing. The National Institutes of Health, if you're interested in biology, has a ton of links there that you can see. And I also just want to make a plug again. You have the right to think I'm crazy for saying this, but read deeply in the humanities. You'll gain a profound appreciation for the beauty of the world and the beauty of what it means to be human. That will only enrich, your sense of humility, awe, and wonder then as you, go and look at the natural world. This false divide that's come up, in the last couple of 100 years is really a painful thing.
Okay, we have a few more questions. One asks, would you regard the notion of the communion of saints as the essential demonstration of the sort of interactivity that exemplifies complexity?
Sure. I wouldn't necessarily say the essential, but I would say it's a absolutely an illustration of what we're seeing, I think. And that's why we shouldn't think of the communion of saints, and I'm not assuming whoever asked the question does think of it this way, as if it's just sort of, the Hall of Justice and all the superheroes are sitting there. The communion of saints is a beautiful illustration of all those who are now and forevermore in the presence of the Lord. But for all of us, we are connected, right? The body of Christ is real. I don't think Paul was just speaking metaphorically. And I don't mean that he was talking about our, electrochemical connections, but the point is, we are connected in our very anthropology. We are in the image and likeness of a Trinitarian God who is love. Right? Those are the three great statements of Christianity. I mean, one comes from obviously the Hebrew scriptures, we're in the image and likeness of God, right? Christianity adds that God is a trinity of persons, inherently relational. First letter of John, God is love, not God is lovable or God is loving, but God is love. So every human being is inherently connected in that way. And then the communion of saints, right? What they've attained is that glorious union, with the divine. So yes, yes, and yes, that's a great way to think about almost every aspect of Christianity for that matter.
Well, I think we have come to about the end of our time together. So we definitely want to give one final thank you to you, Father Carchi. Thank you so much for being here and for your wonderful lecture and for answering these questions. And also thank you to our co-sponsors and to everyone who is tuning in from all over the country. We have people tuning in tonight. So thank you all for being here. Just a few final reminders, like Father Carchi said, please do apply for our Summer Institute. If you know a high school student you think it might be well suited for, we will be discussing truth, goodness, and beauty together with Notre Dame professors Jenny and Jay Martin up at beautiful Mundelein Seminary at the beginning of July. I've put the link in the chat. Let me put a new link. I think it was, it got connected to another word when I put it in the panel. So there, that is the link to the Summer Institute information. To support the work that the Lumen Christi Institute is doing here with our Newman Forum programming, I've also attached the link in the chat. You can donate through our website. And if you're interested in learning more information generally about the Newman Forum, if you've got a youth ministry group or a high school group you'd like to do a small event with us, I've included Austin Walker, the director of the program, his email as well as my email. And we would love to hear from all of you. There's also a survey to fill out you'll receive when you leave the meeting. We welcome your feedback on how to make these sorts of lectures better and better. And we look forward to engaging with all of you very soon at our next event. So thank you, everyone. Have a wonderful evening. Stay safe and well.